Conservation of linear momentum.
The principle of conservation of linear momentum states that in a system of colliding bodies or objects, the total momentum is always conserved provided there is no external force acting on the system. Or if two bodies collide in a closed system, the total momentum before collision is equal to the total momentum after collision. So this gives us the idea that the momentum before there is a collision and the momentum after that collision is always equal. Conservation of linear momentum. So let's say we have two bodies moving in opposite directions. So body A and then body B. Now this is going in this direction and then this one is also moving in this direction. They are moving in opposite directions. So they are moving towards each other. So this is before collision. So we have body A, then body B. Now the moment they collide, so we have body A and then body B. The moment they collide, now let's not forget that as they are moving with different momentums. After collision, what happens is that the bodies might move in one direction depending on the momentum. According to the law of conservation of
Momentum.
in colliding bodies, their force is conserved. Now, let's call the force applied in this direction as a force of the body A, so force of A, then the force of B. So it is conserved means there is no change of force, so it's equal to 0. Now, according to the third law of motion, which is the law of interactions, to every action there is an equal and opposite reaction. So the force applied in this direction is equal and then it is opposite to the force applied in this direction. So the force applied in this direction is equal and opposite to the force applied in this direction, and the negative sign indicates the opposite direction. According to Newton's second law, force is equal to mass times acceleration. So in this case, let's substitute mass times acceleration at wherever we see force. So we end up getting mass multiplying acceleration is equal to mass multiplying acceleration. Let's not forget that this mass is the mass of the body A. So the mass of body A and then the acceleration of body A. In the same way, mass of body B, then acceleration of body B. And let's not forget that they are opposite, so a negative sign here. We also know that acceleration is the rate of change in velocities. So anywhere we see A, which is acceleration, we put in the formula for acceleration. Now at this juncture, let's cancel out the time because the time is the same at both sides. So since the time is the same, and we can cancel out the time to get to deal with the numerators. Now let's expand this bracket. And let's also not forget that this V minus U is for body A, then V minus U for this aspect is also for body B. So this indicates the final velocity minus the initial velocity of body A. So we have this multiplying this gives us Now let's group the ones with the final velocities at one side and then the ones with the initial velocity as one side. Now let's take this example. A body of mass 2 kg moves with an initial velocity of 5 meters per second and collides with another body of mass 15 kg moving at 0.3 meters per second. If after collision, the body of mass 2 kg moves with a velocity of 4 meters per second, what is the velocity of the 15 kg body? Let's try to understand the question. So let's get the data out of the question. Now, a body of mass 2 kg, so we have body A and body B. So this is our body A, then our body B. Now, it says that a body of mass 2 kg, mass of body A is 2 kg, moves with an initial velocity of 5 meters per second. So the body that is moving with that velocity is the body A. So that means an initial velocity, which is represented by U. So the initial velocity of body A is now 5 meters per second and collides with another body of mass 15 kg. So another body, so this is the body. So another body of mass, so mass of the second body is now 15 kilograms, moving at 0.3 meters per second. So the second mass is now moving at 0.3 meters per second, and that is the initial velocity. So the initial velocity of mass B is 0.3 meters per second. If after collision the body of mass 2 kg moves with a velocity of 4 meters per second, now if after collision the body of mass 2 kg, and that body of mass 2 kg is the body A. So in this case, we are saying that if after the collision that body moves 4 meters per second, there is a final movement, so a final velocity for which body? The body of mass 2 kg, and that is body A. So that means our final velocity for body A is now 4 meters per second. First of all, let's check to see what is missing in the parameters. Now, what is the equation? The equation is such that the question was asking us that to find the velocity of the 15 kg body. And the 15 kg body is the body 2, so which is body B. So we are finding the velocity of this body. And which of the velocities were not given for body B? Now we have the initial velocity given, so that means we'll be finding the final velocity here. Now let's put the parameters inside the equation or the formula. So we have our MA, which is 2, multiplying our UA, which is 5, plus our MB, which is 15, multiplying UB, which is 0.3, is equal to our MA, which is 2, multiplying VA is now 4, plus our MB, mass of the second body, which is 15. Now in this case we don't have VB, so that means we'll be finding this. Let's simplify this further. So in this case, our VB is equal to 0.43 meters per second.